This is the fourth video in my series on alternating current. In this video, we are going to define RMS values. You will find this topic along with others in my course entitled Basic Fundamentals of AC Circuit Analysis. You can access this and my other courses on my Stan Store at this web address. As we communicate the value of voltage and current with others in the industry of electrical power, we have to ask ourselves, how useful are using any of the terms, and is there some way of measuring the values that is the most useful way? That question was asked and answered a long time ago, and the answer was the RMS values. Before just jumping to the definition of RMS, which, by the way, is mathematically related proportionally to amplitude, peak, peak-to-peak, average, and mean average values, let's go through some logical steps to get there. Starting with two simple circuits, one DC, one AC. That is, each with the same load, but one driven by DC source and the other driven by an AC source. When we close the switch on the DC circuit, the bulb will light with an intensity that is dependent on the resistance, R sub L, of the light and the DC current. Now, let's close the switch and adjust the AC current to the light bulb with the same intensity. That is to say, both loads, both lights, consume the same average power. So we now ask ourselves, what is that AC current? We can come to the conclusion that if the two bulbs light to the same brightness, that is, they draw the same amount of power, then it is reasonable to consider the current IAC to be in some ways equivalent to the current IDC. So, what is that value of AC? It would be useful if there was some meaningful way to calculate it. So let's go there. If an AC supply is connected to a component of resistance, say R, the instantaneous power dissipated is given by the power equation I squared R. If we plot I squared, the instantaneous current, which itself is a sine wave, it is always positive because plus I times plus I is positive and negative I times negative I is positive. It does go to zero, but never negative. Remember that the instantaneous power dissipated is given by the equation power equals I squared R. The peak or maximum value of I squared is shown here and labeled I squared max. The mean or average value of I squared is I squared max divided by 2. So the average value of power is, and we'll call it P subscript AV, is equal to I max squared over 2 times R subscript L. We just saw from the previous slide that the average power consumed in the circuit is given by this equation, which is equal to the maximum value of the current squared over 2 times the resistor. Let's define a current then that when used to calculate power gives us the average power. In other words, when that current, let's call it I with a subscript defined for now, is squared and multiplied by RL gives us the average power. But the defined or I defined squared is also equal to I max squared over 2. Therefore, the square root of the mean current equals that defined current. So we just discovered that what the value of I defined is equal to I max divided by root 2, and we call this current RMS, or root mean square, and it is 0.707, the value of the maximum current. This is another more useful way to describe AC quantities, voltage and current, and of course it can be converted directly to amplitude peak or peak to peak or average just by multiplying by a scaling factor. However, we use RMS values for current and voltage. We can directly calculate the average power from these root mean square quantities. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also, from time to time, be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of the aforementioned type products. It is also a connection to obtain a free copy of my 24-page 3-phase transformer workbook, which will serve as a quick reference and reminder of technical calculations that you may need. This address, of course, is case sensitive. I'll spell it out and make sure that you have it right. Everything up to the first number is lowercase. That is lowercase https://bit.ly/3, then uppercase U, uppercase G, a lowercase j, uppercase B, uppercase I, and lowercase g. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐿 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐿 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐿's products and obtain a free copy of my 3-phase transformer workbook, check into this web address and simply provide your email address, which will guide you to browse the full extent of their products. There is no cost or commitment for viewing, and by providing your email address, it will allow me to keep you posted on future videos, courses, and 𝐃𝐈𝐒𝐿 products.